Welcome to the part 4 of Apache Kafka fundamental tutorial. So let's start. So Zookeeper and we already have some idea about Kafka. So Zookeeper is kind of a coordination service that manages Kafka. So Zookeeper helps in performing leader elections for partitions. Zookeeper sends notifications to Kafka in case of any changes. For example, we have added some new topic, some broker dies, broker come up, and or we deleted some topic. So basically, Zookeeper, without Zookeeper, Kafka cannot work. Zookeeper by design operates with an odd number of servers. So we usually have one Zookeeper, three Zookeeper, five or seven. So why is that? Basically, suppose we have only one Zookeeper, and in case that Zookeeper dies, then the whole Kafka cluster stops working. So for that reason, we have like three Zookeepers. If we have three Zookeepers, and if one of the Zookeeper dies, then we still have two Zookeepers alive, so they can start functioning normally. Zookeeper also has a leader that handles write operation. The rest of servers are followers. Zookeeper does not store consumer offset with Kafka uh, from version 0.10. Earlier, it used to maintain offsets also, but since Kafka version 0.10, Zookeeper doesn't do that. Only Kafka handles offset. Yeah, so this is a picture where we can see we have three Zookeepers. One of them is the center one is a leader, and there are two followers. And Kafka, there are five brokers. Two brokers are talking with follower, three and four are talking with leader, and fifth is registered with follower. Okay, so for if we have three brokers and somehow the server one dies, so these like broker one and broker two, they'll automatically choose either of server two or server three. Kafka guarantees like messages are appended to a topic partition in the order they are sent. So the in the order where the messages were produced, they will append it to the topic partition in that particular order only. Consumers read messages in the order stored in topic partitions. With a replication factor of n, producers and consumers can tolerate up to n minus 1 broker being down. What does it mean? So, for say, suppose in the last picture we have five brokers. So, n minus 1 is 5 minus 1, 4. So, it can Kafka cluster will not stop working even if four brokers are failed. Even if there is a single broker that is working, the cluster will continue its working. This is why a replication factor of 3 is a good idea. Allows one broker to be taken down for maintenance and another broker to be taken down unexpectedly, which means that broker is stopped somehow due to any error or something. As long as the number of partitions remain constant for a topic, no new partitions are added, the same key will always go to same partition. So suppose we are producing a message with key P1. So this message will always go to a particular partition. Suppose we send some message today and it goes to partition 0. And tomorrow also if we are sending some messages with the same key P1, then it will automatically go to partition 0 only. It will not go to partition 2 or 3 unless and until we have not added more partition to the topic. If we are adding more partitions, then Kafka doesn't guarantee that the order of message is same. It can automatically rebalance. So theory roundup, we have looked at all the Kafka concept. Source system have producers. Producers send messages to Kafka clusters. Kafka clusters have multiple brokers and number of brokers from 101, 102. These are arbitrary numbers, and brokers can be of 100 brokers. Brokers talk to zookeepers. Like zookeeper is a coordination service that manages Kafka cluster. So when message is produced, it is produced in round robin fashion. So first message will go to the one broker, then second and three. If we are sending keys, then message will land to that particular partition only. It will not go to other partitions of a particular topic. Acknowledgement strategy, we already read about acknowledgement strategy like 0, 1, and 2. And brokers have topics, topics have partitions, and brokers have their replication. Like replication is nothing but a copying of that broker. Partition leader and in-sync replicas. Offset topic, when consumer reads from a particular topic, it commits offset so that it remembers, okay, I read, I have already read this message and I don't have to read it again and again. Consumer work always in groups, and it have delivery semantics as at least once, at most once. And zookeepers has leader follower architecture. Broker management, broker management uh, generally means it they manages Kafka brokers. So this is all we had for Apache Kafka fundamentals. I hope after watching this video, you have gained some at least basic knowledge of Kafka, how it works and all. And in next lecture, we'll be doing some practicals, how we can set up Kafka in our system, and how we can send messages, produce messages, and we'll see how Kafka in actual it works. We'll not be making any separate application or something, but we'll only test the Kafka software after downloading.